Are lift wings gonna be the future of aircraft? Wings are widely recognized as one of the most critical, if not the most important, components of an airplane. The advent of lift wings has shown a potential that might be explored, which begs the question, are lift wing aircrafts going to be the future of aviation? Let's start with an overview of aircrafts and lift wings. An aircraft is a vehicle that can fly by utilizing air assistance. It counteracts gravity by employing either static lift or dynamic lift from an airfoil, or in a few situations, downward thrust from jet engines. Airplanes, helicopters, airships, including blimps, gliders, paramotors, and hot air balloons are all forms of aviation, as it generates lift, allowing the jet to leave the ground and take flight, while also holding the fuel. Wings, as a result, have streamlined cross-sections that function as airfoils and are sensitive to aerodynamic forces. However, as everyone with even a rudimentary understanding of the aviation business knows, planes come in a variety of wing designs. Dusan Stan and Alexander Stan created aliptera in Canada. Their aim is to develop freight and small personal, vertical takeoff and landing, or vtol aircrafts. They have a cargo, a one-passenger, and a two-person vtol as of January 2020. While little information regarding the specs of each aircraft is provided on their website, it appears that all of their aircrafts may be changed to be completely electric, hybrid electric, or gas-powered. Lit wing technology, according to the creator, is a wing that is coupled to a movable ducted fan during VTOL flight, allowing the aircraft to lift at zero speed. The wing retracts from the ducted fan when the aircraft transitions from VTOL to forward flight, and the ducted fan rotates from a horizontal to a vertical position. Lit wing technology allows the aircraft to be efficient in both VTOL and forward flight, resulting in a new form of aircraft that is well suited for urban air mobility. The fixed-wing aircraft. A fixed-wing aircraft is capable of flight using wings that generate lift caused by the aircraft's forward airspeed and the shape of the wings. Fixed-wing aircraft are distinct from rotary wing aircraft, in which the wings form a rotor mounted on a spinning shaft or mast, and ornithopters in which the wings flap, in a manner similar to that of a bird. The wings of a fixed-wing aircraft are not necessarily rigid, and airplanes that use wing morphing are all examples of fixed-wing aircraft. Let's take a look at some aviation aircraft. Plane. The plane has been the most efficient air transportation vehicle to date. Although as efficient as it is, it has a few flaws. One of these flaws is that it can stall. The stall is a reduction of lift, and if not corrected, the airplane can crash. Also, it cannot fly slowly. Runways are costly and planes are restricted to taking off and landing on runways. Helicopters. The helicopter is the most efficient hovering aircraft to date. Its flaws are that it is slow, has a retreating blade, and its stall limits the speed. Tiltrotors. The tiltrotors hover and are faster than helicopters, but it is a compromise between a plane and a helicopter. Less efficient in hover compared to a helicopter because of higher disc loading. Less efficient and slower in horizontal flight versus fixed-wing aircraft because the bigger propeller creates more drag. Shrouded propeller or ducted fan. This is more efficient at slow speeds, eliminates tip losses, and creates more thrust. Its major flaw is that it can be designed to be efficient at low and high speeds, but you can only have it efficient for slow or high speeds, not both. Channel wing. The channel wing has a thrust and an open propeller, but it has no control and is not efficient at slow speeds. It adds vibrations to the aircraft and increases the aircraft's weight, but the thrust increase is not that significant. Fixed wings now behind, let's go deep into lift wings. This design incorporates the best of all technologies and is the most efficient for VTOL aircraft, since it generates greater lift at low speeds and can fly at higher forward speeds without reducing drag. It has 65% greater lift than a shrouded propeller and 20% more lift than an exposed propeller. The ADR-1 Dragon Rider Personal Electric Vertical Takeoff and Landing, one-passenger aircraft, has the pilot vertical for VTOL flight and is prone to forward flight. The pilot will be fastened into the aircraft and will wear a parachute for safety. The airplane will also be equipped with its own parachute. In addition, the aircraft will have some form of mesh in front of the propellers to prevent harm if the pilot falls on any of the propellers. A computerized flight controller will operate the aircraft's vtol mode. Lift wing technology permits the development of efficient vertical takeoff and landing aircraft with comparable range, speed, and fuel economy to small planes. The revolutionary lift wing aircraft would be excellent for personal usage, as it could take off and land almost anywhere, eliminating the need for airports and runways. Because the rotor is enclosed in a duct, it is significantly safer than exposed propellers and produces less noise, allowing the aircraft to be utilized in urban locations that are normally inaccessible to standard aircraft. Flight testing of the company's subscale aircraft has already commenced, in addition to ongoing testing of the aliptera APV-1. Specifications of the lift wing. It is a VTOL aircraft that is either electric, hybrid electric, or gas-powered. It features one prone passenger and a single ducted propeller with 3 blades. It features a transparent aircraft canopy that allows the pilot to see in all directions, forward, left, right, down, and up, giving the pilot exceptional vistas and the ability to see the surroundings. It features a fuselage made of composite materials. It features a canard wing and a primary lift wing in the back. The primary lift wing is cylindrical, where it wraps around the fuselage. The location of the main rear lift wing and the rear ducted rear propeller changes depending on whether the aircraft is in vertical or horizontal flight. Pilot personal parachute and aircraft parachute. The ducted propellers will have some kind of mesh, so that the pilot does not get caught in a rotating propeller. In an emergency, the aircraft may also land as a short takeoff landing aircraft. Consider a vehicle that can take off from your driveway and fly to any destination, such as your neighborhood grocery shop or job. Your commuting time is cut in half, from 1 to 2 hours to 10 to 15 minutes. Your 5-hour trip to your favorite getaway location is now only an hour away. Consider the possibilities if you can commute 500 kilometers every day. Consider a vehicle capable of fulfilling each of our dreams of flight, making flying as personal and uncomplicated as it gets. Consider a vehicle that can provide the excitement, thrill, and exhilaration of flying to everyone, everywhere, at any time, making flying exciting again. Consider a vehicle that allows you to explore the wonders of our globe from hitherto unattainable views. Such a vehicle would shorten distances for everyone, shrinking the planet, making it simpler for people to physically interact, freeing up time for each of us to spend with loved ones, and even erasing artificial boundaries between people. The unique lift wing technology enables the creation of efficient vertical takeoff and landing aircraft with range, speed, and fuel economy comparable to small planes. The revolutionary lift wing aircraft would be excellent for personal usage, with the ability to take off and land practically anywhere, eliminating the need for airports and runways. Because the rotor is encased in a duct, it is significantly safer and produces less noise, allowing the aircraft to be utilized in urban locations that are normally inaccessible to standard aircraft. By providing lift even at 0% forward aircraft speed, the lift wing minimizes the power required for hovering. The system reconfigures at high speed to decrease drag, resulting in cruise flying performance equivalent to that of a fixed-wing aircraft. It boasts a 19.04% increase over a shrouded propeller and a 65.97% gain over an open-air propeller. These experiments were carried out with a shroud and lift wing that bears no similarity to an airfoil and whose performance can only be improved by a properly aerodynamically designed shape for a specific purpose. The mechanism is tunable, which improves control and transition when other VTOL ducted fan ideas have a significant pitch. Until recently, airplane wings were primarily stiff. They do have a few moving elements, such as ailerons, which regulate the aircraft's maneuverability, and high lift flaps, which extend from the back of the wings and boost lift during takeoff and landing. However, these smaller portions, like the major wings, are stiff in their own right. The scientists conducted wind tunnel experiments and extensive high-fidelity numerical simulations using Prace supercomputing facilities to develop and perfect their concept. As manufacturers and airlines focus ever more on efficiency improvements, could we see a new shape of planes in the future? Leave your thoughts and questions in the comment section below.